Great. Hello, everybody. Welcome back from lunch. Nice to see you here. So I'm Valerie. I am here today with my friends Sam and Erin to talk about the Earth Engine Community Catalog and ways to bring your own data sets into Earth Engine. So just a quick show of hands. How many of you have worked with data sets from the data catalog, the Earth Engine proper data catalog? Yeah, so you already know the data catalog is our go-to source of data sets that are readily available through Earth Engine. We've got them ingested, they're being actively maintained, there are code snippets, descriptions, all the information you could want about these data sets. But as you probably know from your own work, there are many more data sets out there, which is where the community catalog comes in. And so have any of you here worked with data sets from the community catalog? Awesome. So we've got some users out there. And for those of you who haven't been in the community catalog yet, this is our community curated collection of Earth Engine data sets. It is outside of the data catalog proper, but it has all the same awesome features. These data sets have been ingested. We are working on the back end to some degree to keep them maintained and updated. We've got descriptions and some other great new features that we'll be announcing today. But most importantly, this catalog has been created by users and for users. And so today we're going to dive in a bit more on why the community catalog was created, how it came to be. We're going to give you some updates on the current status of the catalog, and we're going to walk through how you can contribute your own data sets or request data sets that you've come across out there in the wild. We're also going to talk about some different ways to bring data sets in. Now, curating a community catalog, we've had a lot of experience with all sorts of different types of data, all sorts of lessons learned, and so we're going to walk through some of those. And finally, we're going to cover some of the newest features of the community catalog, particularly code snippets and some other good tidbits and updates. So I am going to be managing for our viewers online the chat, so get some questions in there if you have them. And at the end, we're going to make some time for discussion and Q&A. So if you've got questions in the audience, again, if you've got questions online, get them into the chat or keep them in your mind, and we will get back to them with some time at the end. And with that, I am going to hand it over to Erin to give us some history.
Perfect. I'm good. Thanks, Val. Oh, I do need that. Thank you. Perfect. So how did the catalog come to be? Well, I had been loading a bunch of bigger data sets myself for a little while, and that was going all right until I got to the global shoreline data set. And I looked at it and I was like, I can't do this. It has it's just huge. And it's this massive vector thing, and no. And so I asked my friend Sam, I know you like to do crazy things. Could you help me load the global shoreline data set into Earth Engine? And by could you help me, could you do it maybe, please? So he did. And then we talked more about some of the other data sets that I had been curating, and he, of course, had been like curating some of his own, and he came up with the idea of maybe we should put it all together in this community catalog. So rather than it sitting as my private asset, it could sit as this public asset, and so workflows become more reproducible, and then after my research is over, another person can still come along and reproduce the same workflow that I've been doing or build off of it. So we started off 2 years ago by writing a Medium article, so this community data sets and data commons in Google Earth Engine, and then we went from there. So where are we at now? Well, as of October 3rd, we are at 105 terabytes of data, 287 image collections, and 434 feature collections. And so it's big, and it's getting bigger. And how awesome is it that it's all of the data that we're producing and also wanting to use in one place. We're doing it together, and it's not replacing, like Val said, the Earth Engine data catalog. It's just making it faster and giving it another home for right now. So we've been grouping the data sets by categories, and so this is another place where we've been organizing the data sets this way so far, and we're going to be working with the Earth Engine catalog proper to coordinate so that when you look at both catalogs, they'll have really similar structures. But just so you know right now, in the community catalog, there's quite a few more data sets, and in particular, under like the global utilities, assets, and amenities layers, there's a lot more data there. And I bring that up because that's where some of my work sits. So how do you get involved? Well, there are 5 ways. And so we're going to go through these in our talk. And so the first one is, I have a data set. How do I bring my own? The second one is, how do you suggest a data set? The third one will be updating a data set. The fourth one is bug reports. And the fifth one is contributing a code example. And so this is something that's new, and I'm really excited to talk about it. So let's start with the first 2, bringing your own data set and suggesting a data set. So I'm going to hand it off to Sam.
Hey, everyone. I hope you can hear me OK. Before I get started, I want to point at Simon and Kurt, who are sitting there, who maintain the master catalog. So a big round of applause for those 2, because they maintain over 70 petabytes of data. They have a larger team, but these 2 are the main gatekeepers. So go bug them after if you want to talk about data sets in general. I'm going to do a little bit of conversations. By the way, my main role is I'm a solutions architect at Planet. I'm also a Google developer expert working with Google Earth Engine. And a lot of the time, I try working with communities on projects that are impactful, or I hope that are impactful over the long run. So as Erin mentioned, this was a project that started about almost exactly 2 years ago. And I'm hoping to show you exactly how to contribute and keep this growing. So we're going to switch over to the demo right now. OK, so as Erin mentioned, that if you wanted to go to the community catalog and contribute your data sets, let's say that you have generated some data sets, or you know of this amazing paper that generated some data set, but it's not in Google Earth Engine right now, you can actually go to our website, which is g-community-catalog.org. Yes, we have a new home now, so you don't have to go to the github.io pages. You don't have to remember those. We hope that this is an easier website to remember. The other thing you can do is, once you go there, is if you go to the Getting Started pages, you will find that there is now a navigating the catalog. But what I want you to focus on is on the fact that there is now a submit or bring your own data request to community catalog. So when you go there, you are essentially treated with these templates. And these templates allow you to submit your data set. So what we're going to do is, I'm just going to briefly talk through them, but I'm also going to open them in the meantime so that you can see what a template actually looks like. And this will preload a template for you. So imagine you are the author of a data set, and you really want to contribute that to the community catalog. You can choose, say, bring your own data set to the community catalog. And when you open it in a new tab, a new template, a GitHub issue is created. This is where we actually maintain all of the issues, all of the data requests that comes to us. You can go in and say, global movement data, for example, and you wanted to add in some additional information. So you wrote the paper. You know what description should go with it. I always love it when contributors actually go in and write some description, because it's right, and it's the way in which they want to describe the data set. So this is where you will put in your description of the data set. If you already have this data set ingested in Earth Engine, this also happens where some of you might have already ingested the data set in Earth Engine. You have built an Earth Engine app to go with your paper, but you still want that data set or that collection to be discoverable. It's not just for data sets that needs to be ingested. It is also open for data sets that you already have in Earth Engine, but you just want them more discoverable, more accessible for people around the world. So you can directly put in a Google Earth Engine collection table, whatever image that you might have a link to, you can directly add it in there. So I've left that space for you. This is authoritative, right? So this is something that you are proud of, you want to present on. Maybe you have a sample code. Maybe you have an example that you want to go along with the data set. You can also submit the example. And then some additional information that we have asked for can be the fact that I need a license. And this is where I like always say that the first thing when we look at a data set is, what kind of license is it in? And I always implore researchers to say, I understand that research can be sometimes behind paywalls, but make the data sets available. Let other people in the world who may not have as fast of an internet connection to download 10 terabytes of data still be able to play with that 10 terabytes of data by putting it in environments like this. So that was the entire intention of doing this. So there are similarly other templates that we also have, which includes the submit update request. So by the way, you can submit any data set. It doesn't have to be a data set that you have created. You might read a Nature paper, or a science paper, or a paper in any other journal that you want, and you decide that this data set is impactful, you think that more than you or others can actually benefit from that, feel free to submit it. It's not just meant for the creators of the data set. As long as the creators have made it open, I'm happy to add that to the community catalog. You can also talk more about the fact that there is updation of data sets. So we try to keep tabs on multiple data sets to see if there are newer versions available. But as you might imagine, it's a tough job. It's not necessarily something that we know off the bat, like that, hey, this data set now has a new version. A classic example would be there's a version 3 of a new data set that has been released. I love it when communities tag me and they tell us that, hey, there's now a new version of a data set. Please tag us. Please create a template. It's the same idea. You can just go and basically choose to submit, like, hey, there's a data set in your collection. It's version 2. There's a version 3 now available. Could you go ahead and update that? And we're happy to look at it. As long as the license allows us to, we will happily update to the newer version. So I want you to use these templates to basically just think of this as, hey, these are completely editable markdowns, and you can basically go in and do the same things that I'm doing right now in terms of like modifying these, choosing the license type that is made available to you. And last but not least, there is the idea that there is bug reports for data sets in community. If you find a bug, if, like, for example, it has happened once in a while where I'm trying to move from one template to the other. I copied something that was from a different template. I copied an example code from a different template. You see that, you notice it, and you tell us that, hey, there is a bug. Could you update that to this new one, or could you make that correction? We would love to hear about those as well. By the way, all of the scenarios and templates I'm talking about are based on things we already do. I just wanted to make it more standards. That's why we created these templates. So you don't have to ping me or tag me on Twitter. You don't have to send me LinkedIn messages. Though I do appreciate all of those things, you don't have to stop. But I love the fact that you can now have a template, a mechanism to actually do this more formally if you wanted to. And last but not least, this is something new that we wanted to introduce, which is the idea that you are the ones, the communities are the people who are working with specific data sets. If you have specific examples of using this data set in Google Earth Engine that you think is going to really add an impactful flavor to that data set description page, please submit an example. And we will attribute that example to you, and we will make that example available for everyone else in the world to use. So with that in mind, I'm going to switch gears a little bit and talk a little bit about what happens when someone does submit a data set request. If you wouldn't mind going back to the slides again. Thank you. OK, so as I mentioned, the first thing where it starts is the license. We have to look at the license. I've read more license docs in the last 2 years than I would want to. But it's been interesting to learn about different licenses in the world. And it's also interesting because when you're trying to submit data set, I believe a lot of you have struggled with this. They'll give you a drop-down list, and you're just magically supposed to know what those licenses are. I implore you to read and see whether you can, or not you can make it as open as possible. So here we have given like a preferred example might be a CC by 4.0 that's permissive enough that people can utilize it. They can build on top of it. They can mix and match and work with it. If it allows us to redistribute the data, and if we think that it is open enough for us to include it in the catalog, then we move to the next step. If it actually says, please don't redistribute this data, or if it actually is that restrictive, unfortunately, we cannot include those data sets in the community catalog for obvious reasons. But you are more than welcome to download it and then utilize it into your own collections if you wanted to. The next thing we want to make sure is this data set hosted by the requester? We check whether these assets or files are either shared. So someone has to tell us that, hey, I'm going to share this collection with you if this collection is already in Earth Engine, or you have to point me to an FTP or a Zenodo or a Dryad or a Figshare repository and say, this data set sits here, or even a link sometimes that says that this is where all of this data set is, go fetch it. And then it's on us. I'll write some automation pieces, some ways of fetching those data sets in the most efficient way possible, hopefully. And then we try to include those in the next step. So that's what happens next. It goes through the license check. It goes through the asset control. And while I'm doing all of this, the one thing I have to consider is the format of data. Now, while the preferred format for ingest in Google Earth Engine, as you're all aware, is Geotiff or Cloud Optimized Geotiff, the community catalog, we often will accept other data sets, as does the main catalog. Actually, they do conversions in the back end. And same for us. We do conversions. We have the capability of converging from an NC file, for example, to a Geotiff. We will do that at our end. A lot of these computation storage is supported actually by NSF. That gives us a grant basically to run and do a lot of geospatial workbenching. OK. So what I'm going to do right now is take the lessons we learned from bringing data into the community catalog. And we're going to talk about 4 different ways in which you can bring data into Google Earth Engine. And this is applicable for any kind of data that you want to bring at your end. It is not related to the community catalog per se, but I'm using examples from the community catalog just to show you what you can and cannot do. We're going to talk about 4 different things. We're going to talk about the code editor GUI. This is probably the most familiar way in which most people bring data sets, unless you have hundreds and thousands of files. If you do have hundreds and thousands of files, we're going to talk a little bit about the manifest upload. You might have also noticed that there is a mechanism for us to build these things called Earth Engine manifests, and that allows us to also bring in data. We're going to talk about COGs, and these are Cloud Optimized Geotiffs. These are geotiffs that have additional information that's available to them. They allow for range reads. They have overviews, some really neat stuff. And Earth Engine can actually do some interesting things like directly read a COG, which was discussed in an earlier talk, actually, that they can do load URI, and you can directly load a COG. And last but not least, I'm going to talk about COGs as collections, where imagine you have multiple of these COG files, multiple of these Cloud Optimized Geotiffs. What if you want to register it? And what is the benefits, pros and cons, those kind of things? So over the next few slides, we're going to go over the pros and cons, and then I'm going to switch over to actually live demoing how you can bring in different data sets using these 4 mechanisms. OK. So the first one is the GUI. This is the one that most people are familiar with. This is the code editor window where you go in. It's built into the code editor, which means that you don't have to install any packages. You don't have to work on any libraries that can create some dependency issues for you. You can basically go into Earth Engine, and you can click on and submit a data set of your choice. Now, this does require a couple of things. It currently only supports TIFF files. So if you have any other format, you'll have to do the conversion at your end. It also currently only supports single TIFF. If you do pass it multiple TIFFs, they're merged into a single asset. Or if they are spatially overlapping, it might fail. But Simon can correct me if I'm saying that wrong. OK. Currently, you cannot select multiple files, like I said, if there are spatial overlaps. And then there's the maximum size limit. I don't know if many of you upload data sets over 10 gigabytes. I frequently do. And when single files go over 10 gigabyte sizes, the code editor will not allow you to do that. It might be useful for you in that case to try some of the other strategies that I'm going to show you. So these are some of the advantages and disadvantages. Some of the pro tips that I wanted to share with you, this is examples, lessons learned from the community catalog, includes processing is dependent on your upload speed. Keep in mind that when you are reporting on internet speed consists of 2 things, upload and download. Make sure you have a good upload speed. If you don't have a good upload speed, use a VM or a cluster or a computer that you know is connected to a network with a much higher throughput backend, so that you can basically upload something that's much quicker rather than waiting for a gigabyte to happen in like 15 minutes. It's slow, it's painful, and it's just not the right way of doing things. Though I do understand that a lot of you may not have high upload speeds, and I have a similar issue. That's why I use VMs for doing the kind of things we do for Community Catalog. While you can start simultaneous uploads, be careful to avoid too many requests. This is a good one to remember. You don't want to, so initially what happens is when you're starting an upload, it starts to actually upload the data, and then the ingest process actually starts. So what it does is when you click on that button, it generates upload URL. That's what's happening in the backend. And that upload URL is where we are making a post request. So any data set you have, a TIFF file, whatever else you have, it's basically posting to that upload URL. It's getting a response back. That response is usually the GS / with ends with whatever extension that you have given it. And then the system actually submits it to Earth Engine for the ingest process to start. All of this is happening in the backend. You don't usually see it. But if you start multiple of these processes, it may not scale the way you want it to. And you don't want, while an image is uploading, for it to crash. You don't want your browser window to actually crash. So don't try doing 20 or 30 of simultaneous uploads, even if you're really good at clicking quickly and switching between tabs. Just be careful of that. And do not close your browser tab while uploads are in progress. This is only when uploads are in progress. And the way you'll know that, it actually will say uploading. Instead of saying ingesting, there won't be a gear wheel running or anything like that. It'll actually say uploading. While it's doing that, do not close your tab. It will kill the upload process. Okay. Now, if your data sets are more than 10 gigabytes, or even if they're smaller than 10 gigabytes actually, but you really wanted to create a more granular mechanism of uploading data, Manifest is probably one of my favorite ways of interacting with Google Earth Engine. And it gives you the most granular control over everything like what is the band name, what other properties do I want to add to a data, start date, end date. Now, with COGS, you can do something similar, but as you'll realize that there's some additional granularity that you can get with Manifest that you may not have with other forms of upload. Manifests are essentially a JSON file. They are structured in a way that allows the computer or allows the URL to the endpoint to actually know that, hey, here is where the image is or here is where the object is. And then it basically has all the properties that you want to pass. You can pass it as start date and end date, things like that. And if you go into the Earth Engine guide right now, you'll be able to find an entire section just on different types of manifests. So I implore you to actually do that. We'll be doing a series of articles on all of these 4 methods that go into much more detail than what I'm going today, by the way. So some of the advantages, more granular control, like I just said, supports multi-file mosaics and band stacking, which means you can actually pass it a list of TIFF files, for example, if you have them already in Google Cloud Storage. It allows you to set details like band names, masking policy, pyramiding, all of the things that you're doing using the GUI, you can actually do using the manifest as well. And in fact, that's what happens when Earth Engine GUI creates an ingest job. It's in the backend, it's creating a manifest for you. Again, you don't see it, but that's what's happening. So disadvantages, Manifest currently assumes that the files are already in the Google Cloud Storage bucket. If you have a local file, right, and if you're uploading it using the code editor, it was very easy because you didn't have to put it in a Google Cloud Storage bucket, get the URI. It kind of is already handled for you. In this case, this is useful for people who have a Google Cloud Storage bucket and say that we want to just ingest using that mechanism. And then there's some pro tips that I want to share was configure permissions for the bucket before attempting an ingest. It's very important that Earth Engine can read your bucket. And make sure you use the URI prefix in case your manifest exceeds 10 MB. There is a limit on how large that JSON file can be, so be careful how large that JSON file is. Okay, last one is, the 2 last ones are the direct cog reads on E scripts. I'm just going to go quickly over the advantages of this one. This is useful for single cog reads. If you have a cloud-optimized geotiffs, you can point to existing asset and you can basically ingest it. Or you can basically load it into a code editor window, no ingest required. This is useful for people who already know that their assets are cloud-optimized Geotiff. It does not currently have, you can pass it like objects like lists, but right now it's doing a single cog read, and it feels responsive and allows for a quick test for scalability. Disadvantages, it currently only supports a single file read, like I said. Loops and iteration in a code editor window is a big no-no. We wouldn't recommend you try iterating through multiple of these so you can basically try to make a collection. I'll show you a better way of making a cog collection. Must include the necessary overviews for easy rendering. This is a concept for those who are actually creating cogs. There is an entire section, again, in the Earth Engine guide that tells you about overviews and what overviews to create. So make sure you read that piece. And the pro tips would be that the TIFFs must be tiled and must contain overviews because it won't render properly in Earth Engine. And sometimes it'll just give you a memory error or it'll just throw an error, but it won't actually necessarily make sense to you. And the last one is registering multiple cogs for a collection is a better approach than reading multiple TIFFs, which is the last option, where what we're doing here is, in the script, the animation that's actually running is exactly what I'm going to show you. The cog collection allows you to register multiple cogs. It also starts with having all of your assets in a Google Cloud Storage bucket. And as Brady said in an earlier talk, remember that cloud storage is not a free service. So this part does require you to have a billable paid for cloud storage bucket. You keep all your assets there as cloud-optimized Geotiffs. And what this workflow will allow you to do is register them as collections. And register, unlike ingestion, is almost instantaneous. So the benefit is also the fact that there is no wait time for ingestion. If you're doing a 10 gigabyte TIFF ingest, it'll take a while. If you do a 10 gigabyte registration, it will probably be a couple of seconds, but that's pretty much it. So it does have that flexibility. In terms of disadvantages, cog collections uses a simple payload. You can't pass some very explicit information, like you can't pass band names and explicit naming conventions like the way you want it to. You can pass properties, just like a normal image collection you can for the ingest jobs, but some granularities are missing for the cogs versus the ingest manifest. The other thing is that there is currently no server-side validation for cog overviews, which means you may not know that the cogs don't have overviews till you try to actually register them, and it may or may not throw an error for you. So recommendation is you check whether or not they have overviews at your end. And last one is pro tips include that place most cog assets in a single bucket to avoid permission issues. This is really critical. I've seen people who have folders and subfolders and things like that, and then you have granular control. Cloud-optimized Geotiffs are really reliant on the underlying assets and the permissions, whether they have been set properly with users, which means that if you're sharing a collection with some external user, someone else, remember, not only do you have to share the collection, you also have to share read permissions to the bucket, because those two are linked. Cloud-optimized Geotiff registration is just a pointer to that object in a cloud storage bucket. So it does require you an extra step to make sure that your permissions are configured properly when you're sharing a collection or anything else that you want to share. Okay, so I'm going to go into live demo again, and we're going to quickly just go over exactly what I talked about. So the 4 methods. If you don't mind switching to the live demo, please. Thank you. So a couple of things. I am going to make sure that the first thing I have, I'm going to just pull in and I'm going to show you how to use the GUI. Now, I know that most of you already know this, but when you click on the new link right here, you have an upload, image upload, you have Geotiff. When you're clicking here, this is the point at which it is actually generating an upload URL. You're passing it some names. It's generating it when you're clicking on the source file. You can choose a TIFF of your choosing, and then you pass some properties. So you can pass like the pyramiding policy. You can pass like a masking if you know the no data value, for example, or things like that. You can add a start time, end time, and so on. And then you can click on upload. I'm not going to actually upload anything in this case, but I think it's pretty self-explanatory. And it's probably the easiest point of entry if you're doing just a few images offhand. Okay. The next one is a cog read, where what I have here, and I hope people can see it. I'm pretty sure they can, actually. It's a pretty large screen. If you look at what I'm doing right now is I have a bucket, and I have some data. This is actually the land cover net data from ML Hub. So I have the North America data loaded. I actually have the path here. So I have a script that's written on here. I'm going to just click run. And you will notice here that the image was added almost instantaneously. This is not an ingested data set. It's actually pointing to a TIFF file that's sitting in a Google Cloud Storage bucket. It's still very useful for people to do this when they wanted to run experiments. Let's say you have a very large COG file somewhere that you really wanted to bring in. This is a neat way of actually doing that. It does require you to, like I said, that bucket to have permission so that Earth Engine can actually read that. OK, so this was very easy. The next thing I wanted to show you was the fact that we can do a COG registration. So I have some scripts here. This is the same thing that you were watching a few seconds ago. And I have some collections here. So I want to show you that in my assets, I have two collections. One is known as COG collection, and one is known as COG ingest. So what I'm going to do is I'm going to attempt both of those things. I'm going to do a COG collection, and then I'm going to do a COG ingest. So in the COG collection right now, it's like almost like showing a magic trick, right? Because you have to show them that it's an empty collection first. I didn't ingest the data already, didn't register anything already. It does have 0 images. And what I'm going to do right now is I'm going to run this script. It's a pretty simple script. All I'm doing is I'm initializing. And yes, you can pass credentials if you wanted to. I already have Earth Engine initialized on my system. But if you wanted to, you can pass cloud credentials, service account credentials, anything else that you want to pass. I have a payload. This is the same as the JSON payload as for manifest. This is a JSON blob, if you can think about that. So that's what I'm calling as a payload. And it passes a URI right now, which is the path to this TIFF file. I gave it a tile ID, which was just the tile ID from the name. So I just thought I'll pass one property just to show that properties get registered as well. I gave it a start date and an end date. And then I'm just using the create asset. Now, the beauty of this is because you already have a collection. By the way, you can actually automate collection creation as well. But because you already have a collection, this is going to be registered inside that collection. And that's what we're going to attempt. So if I hit run right now, I should get some results out of this. It's basically telling me what the asset is. I get a very nice readout. I'm going to go back right here. And what I'm going to do is I'm going to delete this section completely. And I'm going to go into the COG collection right now. And what you will notice here is it gives me number of images 1. The file size, however, is nan bytes. The reason being because we didn't actually ingest any data. We were just registering an image. Okay? That's the difference. So now I can go in, and if I go to the image, you will notice that I have the images. It has some additional information like bands and properties that are already pre-computed. And the properties include the tile ID that is passed as a property. So if you wanted to do this for hundreds of objects, you can absolutely register hundreds and thousands of objects, and it will not use your Earth Engine coda. That's the other amazing thing, right? So you have the 250 gigabytes limit. You have a terabyte of data. COG might be the way to go if you're OK with paying for a little bit of storage. OK, and then I can import this into the collection. And here, what I'm going to do is I'm just going to call B0 and B1. I'm just going to hit run. And yes, I am able to add this as an image, just like I was able to directly read the COG. So it'll work just like I worked in the past. But you're also able to bring in the collection if you wanted to and do anything else that you wanted to do with the collection. So I can actually go and say image collection.size, and I can hit run, and you are going to get the results that you expect. Last but not least is we're going to do, so we did COG registration, we did COG read, we're going to do an image ingest, and that should be quick enough. For many of you who have used the command line tool, hopefully we're going to go through this quickly. Let's see. So if you have used Earth Engine, make sure you have authenticated this. I'm going to do an upload image, and I believe you can pass manifest directly. And I have a TIFF file with the manifest information. And the TIFF file is essentially looks very similar to your cog, but it has some additional information. So I'm calling B0 as B1, for example. I want the first band name to start as B1 rather than B0. I'm passing it. The second band name is Q1 because it's a quality band, so I can actually pass Q1 in here. I set it some additional properties if I wanted to, and similarly start time and end time. Okay, so all I'm going to do is I'm going to go and copy this path, and we're going to run this. So it'll be tiff manifest.json. Hopefully it'll start a task. Okay, so you get a task ID, great. It started an ingest task. And the way I know about this is now I have something running here that's already in my task queue. This takes a few seconds to actually register, but this is the whole idea. These are the 4 methods in which you can actually bring your data sets into Google Earth Engine. We're going to be writing much more detailed write-outs, almost like a medium series, if you can, of each of these methods that go into detail, how to set up cloud properly, how to set up a cloud storage bucket, and all of those things. Just look forward to those. If you can switch back to the slides again, please. I believe I'm going to now pass it back to Erin.
Yes, you are.
Thank you.
So as Sam talked about, there are these 3 other features. So we've been going over bringing data sets in, suggesting data sets, which you can do. So now let's talk about updating data sets and bug reports for a little bit, and then we'll follow up with some code examples. So what's the difference? So, and why would you do these things? So you notice a data set gets updated, and this can be really important, especially if you're going to be publishing. You want to be publishing with the most recent version. And so my suggestion is it's good practice to check, are you working with the most recent version of a data set? And in Community Catalog, we're actually automating some of that for you. But if we're not automating it and you notice that it's happened or you've updated your data set, then you can file an update datasets request, like Sam showed you in the template. The other thing is that something is wrong with the data set. And so like Sam mentioned, that can come from ingestion issues. The other thing is that a lot of data has problems, and I say this working heavily in the Arctic. A lot of data does not work as well in our areas. And so right now, bug reports really refer to often technical issues, but that's something I think we should be thinking about a little bit more as well, is what if you notice that a data set is obviously not working in your area? Should you file a bug report? I think that's something that we need to be talking more about to be better documenting some of these issues, especially with some of the big global data sets that are coming out and becoming the norm. So like I mentioned, updating data sets, this is really important. So a great example that I've been working with is the global power plant data set. There's a version hosted in the Earth Engine main catalog. There are 2 much more recent versions, though, that have come up that have substantial updates. And so there had been the newer version in the community catalog, and then there's the most updated version as well. And so I filed an update data set report, and Sam was like, we already did it. And I was like, are you really, really sure? And then he was really, really sure. So that was awesome. So bug reports are the same idea. You just use the template. So moving on. So code examples, though. Code examples are a big deal. And they're a big deal because, so the data sits in Earth Engine. That's awesome. We have a lot of documentation, but I said a long time ago, I want to just be able to look at it. And so now the main catalog and our catalog both have great examples of what the name of the data set is, how do you visualize it, and that pops up. Awesome. Well, what do we actually do? Well, what we actually do, especially if it's a new data set, is we look at it, but then we often want to compare it to something else. And so that's one of the obvious places that you could contribute code examples. And so like Sam mentioned, we have a new form. We want to be attributing it to you. You can submit examples using the code editor, links, Colab notebooks, or other binder-like mediums. We really want to promote code examples that help new users or even experienced users better understand the data in the catalog. And so That's really helpful for people working across disciplines to understand what common conventions look like and comparisons. And of course, like I mentioned, there are limitations with data. No data set is perfect. And knowledge of when and where and how this occurs is really valuable. So we really encourage you to contribute examples, to share what you know with others so they can understand it and maybe help to fix it. This is super valuable at 2 points on a project, at the start of projects when people are designing them, and then because data moves so quickly, it's also really helpful before you go to submit it or publish it, go check again, because maybe something's happened, and this is really important to include. So, and again, if you use this information, remember to attribute it, and we encourage you to follow up with both the contributor and the dataset owner if you're interested in further discussions. And so yeah, so do you need some inspiration? Well, there's 2 really great sources for putting code examples together. So the new cloud-based remote sensing with Google Earth Engine textbook. I'm a contributor to that. And then, of course, the community tutorial. So there's some great style guides in both of those resources to follow. So a little recap. 5 ways to contribute to the community catalog. You can bring your own data. You can suggest data sets. You can update data sets, you can file bug reports, and now you can contribute code examples. And so with that, I'm gonna hand it back over to Sam for a quick little overview of the website.
Yeah, we wanted to show you the new website because I think we finished working on it Monday. So we wanted to show you some of the improvements that we have made apart from the templates. And I believe, so some of the new things, yes, we have a new address. Like I said, it was hosted on GitHub for a long time. It still readouts via GitHub, but it now has at least a new address, so it'll be hopefully easy enough to remember. It's just gee-community-catalog.org. I know it's a mouthful, but hopefully at least it'll be easy enough to remember. There is now the first release. So people have asked me for a long time if the catalog itself can have a release because they would like the catalog to be citable or for them to reference the catalog. So the catalog actually now does have a 1.0.0 release as of day before yesterday. The reason we did a release also as a major release was also because we have been running this catalog for about a year now, so we thought a major release was more important. So that's why we now have a release, which also makes it citable. It has a DOI and so on. And the idea is to do this every month. And now we also have a new examples repo. So going back to things that we'll want to learn from Earth Engine and the Earth Engine main catalog and the Earth Engine main, like the main setup is the fact that when you register for a new Earth Engine account, apart from the owner, reader, and writer repos or reader sections, you also have an examples folder. And that examples folder contains examples of almost every single data set that is in the main catalog. And that's really, really inspiring. So we thought, why not do the same thing for us? So we also released that as a feature. So I'm just going to go and show you the website. If you don't mind switching to the live demo, please. Thank you. OK, so this is the main page for the GE catalog. If you go here, you will notice that you will have a few links right here. By the way, this is our new logo, so hopefully you like it. We also have a new citation right here. We obviously have the getting started section. This is a section that we discussed with you. We run these stats every month. So the stats run and the catalog citation will change every month. So we're just going to do progressive citations. This makes life easier for everyone actually working on this. I would love people to volunteer for this. If you want to review data sets with me, please let me know. Meet me after this. Okay. There's all these sections that you can look into. You can go and visit any data set that you want to look at. The data set structures are essentially a description. There is some snippet of what it looks like. There's an Earth Engine snippet. And now there's a sample code. The thing about the repo is the fact that you can now also add this repo to your list of repos. So it will appear in your reader list. So you can actually have a repository that has basically all of this. And I'm just going to show you. I believe I'm a writer on this one. So bear with me, because for you, it should be a reader. But essentially, you have all of these catalog objects now as examples that are available to you. And as we add new data sets, this repository will also keep growing. And since you will all have this loaded in your read folder, you'll be able to go in and say, I want to look at a global land use land cover data, and we want to look at the land use land cover data from SD, for example. I can go there, and I can hit run, and this will just add this directly. So hopefully this is useful for everyone. And again, this was a lesson that we learned from the fact that there is an examples folder preloaded for everybody. So we hope that you go and accept that part as well. And also, the catalog does have features similar to what the main catalog does, in the sense that if I wanted to look for a specific data set, I can actually do keyword searches. I can look for fire. I can look for flooding. So I can look at actually the word flood, and it'll show up. So you can search by tags, keywords, author names. All of those things are still built in, and you're able to do that in the catalog. So with that, I'm going to pass it back to Erin. And I think it's Val who's going to come out.
Val.
So, community catalog, community discussion. I figure we can take some time to answer some of the questions that have been coming in online. And if folks in the audience have questions as well, I think we've got some microphones up front that we can use. So, everyone maybe stand up and join me here. One of our first questions, are there any potential plans for integrating both the community catalog and the public catalog?
I think Simon should answer that.
Yeah.
So hi, this is a natural question. I expected this to happen. Yes, there are plans. There are no concrete plans because we've only recently started talking with Sam and the other folks about doing this more seriously in the last literally few days and weeks. So we have tons of ideas. We don't know exactly how this, what will occur. So, but I very, very much appreciate, and I think all of us appreciate all this work that you guys have been doing. This is awesome. We need to have more data. We just need to kind of sit down and think how to bring them closer together.
Thanks, Sam.
Awesome. We've got a few prompts up here too, if anyone's thinking about what might be missing, what we could do to better support contributions, things about stack integration, other catalogs. But going back to some of our online questions, what are some of the most requested data sets?
I think land use land cover was the most requested one. I believe that was the one where someone tagged me on Twitter and said, hey, they released this yesterday. Can we have this? And I was like, sure, let's look into it. And we added that data set in 2 days. That was pretty interesting. And people liked that. People played around with it. So I think that land use land cover gets requested a lot, and so does elevation. There's like, I think, 5 or 6 different varieties of elevation data sets that are in there. Yeah.
Yeah, so there's, like I mentioned, there's also quite a bit more on the built environment in the community catalog right now. And so when you're looking at like comparing, so in the Earth Engine textbook, I actually used data from the community catalog, and then I compared it. I think we did a calculation of which state had the most roads affected by flooding or something like that. And so it combined flooding data in the main catalog with the road data in the community catalog. So there's a lot of opportunity to look at intersections, and that data is coming out very quickly, and that's where that iteration process and that feedback is really important, because that data is I would say, still in revision. So yeah.
Awesome. I think we've got a question here in the audience.
Actually, 2 comments and a question. First comment is, thank you for emphasizing the code examples, because I actually think that's the killer feature and what makes the Earth Engine data catalog one of the best that exists. Mm-hmm. Catalog stats is awesome, Simon. Really good idea. That would be fantastic to have on the main data catalog if it doesn't already exist in some place that I don't know about. And my question is, do GDAL cog export defaults produce Google Earth Engine valid cogs? Do we need to munge around with those settings at all?
Yeah, you can configure the settings, but yes, you can export a cog directly using GDAL.
Okay.
Yeah.
Some great questions. Another one from the audience?
Oh, yes. Hello, Sam. Hello, Erin. Thank you so much for your talk. I'm Sheila from UMD. Sam, you've helped us a lot in ingesting cogs from Google Cloud. My question for the community data set is, what kind of quality monitoring is there in place? Because coming from like a geography background, like what are the ground truths they're using? Like what sort of validation is being done? And will that be part of the description for these data sets that are being hosted?
Yeah, that's a great question. That's something that we have been talking about recently. And I think that's why Erin chuckled, because quality is a very hard thing to moderate, right? And for us to go through the quality impacts, when this community catalog was started, the idea was that we will go through the paper, but we are obviously not domain experts on everything. We are usually taking the request that comes in from different users, but we're not trying to compare and contrast one paper versus the other. So it's very hard to say that this is the paper, and you should use this data set as the winner. But I think we are trying to at least to be careful to see, like, is this at least a well-cited paper, or maybe at least it's in an area that's in a journal, or there is at least some backing, something that people can read about the methodology, and that's open enough for people to actually read. So we try that.
Well, and I was going to say that's I think the point of the community catalog too, is actually so that we can do it together, because there isn't a prescriptive formula for this right now. And as a domain expert, when you come in, like you're coming into, in a lot of areas, like pretty deep assumptions from the domains about like how to describe error, what's acceptable. And when we're like where geospatial analysis is going is still within those domain expertise, but there's an incredible amount of synthesis going as well. And when you hit that synthesis side, you start to just find a lot more interesting things in the data, is what I would say, and unexpected interactions. And so that's why I think the first, why like the code examples are such a really important first step. So like which data set should you be comparing? That's what I suggested to Simon. I was like I know what I show, but I have like many years of experience, and I'm like looking for pretty specific things. And so I think that's what we need to start, is that like giving more examples, having a place to have these discussions, and understanding that that we do want to be looking for these metrics, but that it will almost certainly remain a conversation, and this is like an essential part of research. So yeah, so I really appreciate it.
I guess as a follow-up comment, would you then be suggesting like an intercomparison, like a community-driven intercomparison study of all these data sets that are supposed to show the same thing? Hopefully they match up together.
What I'll tell you is we've been talking about putting a peer-reviewed publication together. That's exactly what we'll probably be showing an example of.
It's just one domain, though. We're
yeah,
not
just one domain.
Okay,
It's just one domain.
Yeah. But in the literature right now, there's a number of these examples that have started to exist, and even within them, I can tell you that there isn't a set way for doing it right now. So yeah.
Okay, thank you.
Yeah, of course, Simon.
This, I think, is actually the most important thing to do. I would actually say that all this activity should be counted as quality control. The fact that we have some files, catalogs, it's all kind of incidental. So the point is to actually produce, good data. And so I don't know how to do it. I don't think anybody does, because there are lots of kind of separate standards. If somebody has some systematic way of annotating what data are, like in more than just strings, and how to actually track quality control, how do we say there are missing pixels, missing dates, missing anything, please talk to me, because I think it's super important.
Yeah, and one thing I'll add, putting on my policy hat, is that we don't need perfect data. What we need to know is when there's a problem. So often in a data set, a lot of it is really good, and sometimes there's problems with it. And knowing that there's a problem is more important than necessarily fixing it like right away, is what I would say. So I think it's really important to be cognizant of like that as a first step. So.
I guess along similar lines, we had a question online of whether there is an expectation to have the data set linked to a peer-reviewed publication.
Yes.
So based on your previous answer, I'm getting a sense yes, but does that citation show up in the page?
Yes. So if I may switch to the live for just a second. Okay, thank you. So if you go right now into any of these data sets, essentially there'll be a description But the thing that follows almost immediately after the description is the citation. And because it's not data sets that I am generating, right? It's a data set that I'm curating, collecting on everyone's behalf, right? So we want to include citation. So all data sets include citation, include where they are, include an example code, and a license information. So this is a good example, by the way. This is CC by NC, right? So it means it cannot be used for non-commercial purposes, and it has to be shared alike. So CC by NC SA means non-commercial share alike. And I've just memorized all of these licenses at this point. But the idea is that you can actually look at the license, you can see what fits your need, and then you can utilize them. But yes, all of them have citations. Sorry, if you don't mind going back to the slides again, please. Thank you.
A question in the audience.
Sure. Hi, thanks so much for your work. I think it's really important and super valuable to make data accessible like this. And I think about code examples is amazing and really helpful. So I'm wondering if you have plans to make some code examples of how this process works available, so like how you ingest data sets or interest in that. And you've shared some of your lessons learned today, but I think there's a lot of people in this room who could benefit from those. And
absolutely. And there's going to be an entire series. So after we finish with this talk, just a description of the catalog and everything. There'll be a Medium article that talks about the catalog. It goes a little bit into what you all saw today in terms of the catalog itself. I'm going to be working on a series that is going to go into much more in-depth detail on each of those 4 methods that I talked about. We will talk about what exactly is a cog, and Stace asked about how exactly do you make one using GDAL. Yes, we'll include a command to do that. I would love to show, and that would hopefully be a Medium series where we do these 4 methods.
Yeah, but I really appreciate your point about like how to make a good code example. And so Val, I'm tagging you and I for that actually to like walk through some of our thought process behind it to you. And so like I said, I work in Arctic regions, and so for me, I'll tell you a secret. I was recently working in data, or I recently started up a project. I looked at the data in Anchorage, one of the major cities. It looked great, and I was like, awesome. This'll be no problem, and I hope my fellows are listening. But then when we went and we started checking the data further outside of the major city, it really broke down. And so some of these like lessons learned, best practices, I'd be happy to share. And so yeah.
And great suggestion. Thank you.
Thank you very much.
One more in the audience.
Yes, you raised multiple times the question of the license, and I was curious, can we filter out by license in the website?
Filter out by what?
By license, like for example, our commercial usage, I can like just
yeah, actually, the thing I did not show, and I don't want to do this flip between slides and live, so I'm not going to show it, but we actually have a stack representation of all of this. Actually, all the rasters right now, I'm working on getting all the tables done, and that has the license information. So you can actually go in and basically do, like, show me all the data sets belonging to a specific license, similar to what you can do with the Earth Engine stack catalog right now. But we have a stack version of this entire catalog. This is what I think Stace wanted to know as well, but yes, you can absolutely do that.
Okay.
All right. Can we flip to one more slide?
Yeah.
Just in our last minute here, so just wrapping up thoughts, the Earth Engine Community Catalog is awesome, as the logo says. And as Sam mentioned, we're going to be doing a series of Medium articles on all of the tips and tricks and kind of expanding on some of the points made today. So stay tuned on Medium. Tag us in data sets, so hashtag awesome GEE data sets for users by users and Geo for Good 2022. And thank you to everyone for joining us today. You can also find us on social media or LinkedIn, putting up the short link to the slide deck. There were some questions about whether the materials would be made available. All of the slides will be posted on the conference website after our sessions, and we hope to see you around. Get those data set requests in there and help us continue to grow the catalog with your data. And with that, I will close it out, and thank you all for being here.
Thank you so much, Val.